Hello everyone. Welcome to a boring introduction to data structures and algorithms. I've always wondered why we read about data structures and algorithms, and I never really had a clear idea until I got into programming for a company. I always thought it was more for interview questions, but as you write programs, you realize how data structures and algorithms can help you write better code. So, this course is targeted to anyone who is interested in learning data structures and algorithms, be it for programming or for coding interviews. First, let us understand why we study data structures and algorithms. You probably already know that at hardware level, we have developed multi-core processors and new architectures to increase the speed of computers. So from the dawn of humanity, we have always tried to increase the performance of any technology that we have developed. Going by the same rule, we developed algorithms to increase the speed of code and make our program more efficient. So broadly, computer science research and development can be divided into hardware, where you have multi-core processors, quantum computing, and things like these that are being researched on to increase the efficiency of computer. And then on the software level, you have things like algorithms and data structures that are used to increase the performance of your code. So not just for interviews, but for understanding programming better, you need to have a great understanding of data structures and algorithm, which is what I'm trying to address by this course. So let us talk about data structures first. Data structure provides systematic ways to organize and store data in computer system, much like a well-organized library, which makes it easier to locate books. The organization of data is crucial for efficient access, search, retrieval, and modification of information stored in these data structures. Let's take an example of an array. Array with their contiguous memory allocation and indexing mechanism enable constant time access of elements irrespective of the array size. This efficiency is paramount for performance critical application. We will study array in depth, but just for now, if you don't already know what arrays are, it's essentially a list of data, where each data is stored in contiguous blocks of memory, and you have indexes starting usually from 0 that you can use to access that element. So if I wanted to access L in this array, I would just use index 2. Similarly, if I wanted to access A, I would just use index 0. Now, what are algorithms? Algorithms, which are essentially a set of instructions of solving a specific computation problems. They heavily rely on appropriate data structures for optimal performance. You will see that the choice of data structure directly influences an algorithm's efficiency in terms of both time and space complexity. We use a lot of algorithms when deciding what to do in our daily lives. So if you were making a smoothie, you probably have already developed an algorithm. That is, if you have this fruit, you want to make it that way. But if you don't have that fruit, but you have another fruit available, you can make it another way. Similarly, algorithms are a set of instructions that tell your program how to perform an operation. Data structures and algorithms go hand in hand. For instance, using a sorted array allows for a logarithmic time searching using algorithms like binary search, whereas if you have an unsorted array, it might necessitate a linear time search. Similarly, the selection of specific data structures like heaps or hash tables can drastically improve the efficiency of tasks like sorting and searching. So you can say data structures and algorithms are not isolated concepts, but rather serve as a foundational building blocks for countless software systems and applications. For example, arrays underpin database management system for efficient record handling and are used in image processing to represent pixel data. They can also be used to build more complex data structures like B-trees. Beyond the examples provided, data structures and algorithms are instrumental in operating systems. For example, process scheduling algorithms use queues. And then you have search engines that rely on indexing and ranking web pages. Then machine learning, where you have manipulation of data using different data structures and algorithms. So the key takeaways from this are that for efficient use of computational resources, both time and space is primary concern. Data structures and algorithms are tools for achieving this efficiency. The choice of data structure and algorithm is often dictated by the specific problem being solved and the constraints of the application. Please note that there is no one-size-fits-all solution. Understanding these trade-offs associated with different data structures is vital, which is what we are going to do in this course. Data structures and algorithms are foundational concepts in computer science. They shape how you think about, design, and implement software solutions across a wide spectrum of applications. Now, what are we going to cover in this course? We will obviously cover different data structures and algorithms. We will also cover big O notation, search algorithms, data structures like, but not limited to, trees, linked lists, graphs, and recursion of course. This is just to give you an overview, but I'm going to cover much more. So I hope you are excited for this. Until next time, happy coding.